Welcome to Study Loop.
Hey, welcome to the video. From the given data, initially the number of moles of reactants present can be calculated from the molarity equation, where molarity is equal to number of moles divided by volume in liters, and on equating this we would get the number of moles to be equal to molarity into volume in liters. Here initially we are given the molarity to be equal to 2.00 into 10 to the power minus 3 and volume in liters is equal to 0.005, which on equating we would get n to be equal to 10 into 10 to the power minus 6 moles. Therefore initially there will be 10 into 10 to the power minus 6 moles of Fe3 plus and 10 into 10 to the power minus 6 moles of SCN minus. At equilibrium, the volume, that is total volume of the solution, will be equal to sum of the volume of the reactants, which should be equal to 5 plus 5 ml, which is equal to 10 ml, and on liters it will be 0.01 liters. And we know that the concentration of the complex ion formed, which is the given value, is equal to 1.40 into 10 to the power minus 4m. Therefore n would be equal to, from the molarity equation, that is the number of moles of FeSCN 2 plus complex would be equal to 1.40 into 10 to the power minus 4 into 0.01, which equates to 1.40 into 10 to the power minus 6 moles. Therefore at equilibrium, in 10 ml of solution, 1.40 into 10 to the power minus 6 moles of FeSCN2 plus exist. Here at dissociation, if 1.40 into 10 to the power minus 6 moles of the complex FeCN is formed, this will be equal to the number of moles of reactants, that is Fe3 plus and SCN minus ions dissociated. Therefore the number of ions dissociated would be 1.40 into 10 to the power minus 6 moles. So therefore from this we can conclude that 1.40 into 10 to the power minus 6 moles of Fe3 plus and SCN minus each gets dissociated. And at equilibrium, the number of moles of concentration of the reactants produced would be equal to the initial concentration, that is the initial number of moles minus the dissociated number of moles. Therefore the number of moles at equilibrium will be equal to initial number of moles present is 10 into 10 to the power minus 6 minus 1 0.40 into 10 to the power minus 6. That is the dissociated amount of moles, on which we would get the answer to be equal to 8.6 into 10 to the power minus 6 moles. Therefore, at equilibrium, 8.6 into 10 to the power minus 6 number of moles of Fe3 plus moles is present, and 8.6 into 10 to the power minus 6 moles of thiocyanate ion will be present. From this, if we draw the ice table, it would be Fe3 plus SCN minus gives FeSCN, and it will be 10 into 10 to the power minus 6, 10 into 10 to the power minus 6, 0, and from this minus 1.40 into 10 to the power minus 6 would get dissociated to form 1.40 into 10 to the power minus 6, and we would get 8.6 into 10 to the power minus 6 at equilibrium. And Kc would be equal to 1.40 into 10 to the power minus 6 divided by 8.6 into 10 to the power minus 6 the whole power, which is equal to 1.89 into 10 to the power 2. Hope the video was useful. Thank you.